Hey everyone, this is Bhargav Suthar, and today we are continuing with the topic set theory, and basically this is the third part of this topic. Now in this today's session we will discuss cardinality of a set, a principle of inclusion and exclusion. Okay. Now first let us understand the example based on the previous session, that is the Venn diagram. Now the question is, using Venn diagram, show that this A union B bar intersection C equals to A union B bar intersection A union C. We need to show this using Venn diagram. Okay, so first what we'll do, we will draw some of the Venn diagrams. Okay, so the first step, what is the first step? That is, for left hand side we need B bar intersection C. So for that, first, what is B bar? So see, we have three sets A, B, C. Okay, now B bar. So except all this all just shaded part, that is B bar. So this is the B bar. Now next step, we will find this B bar intersection C. So the second step will be this. This is the B bar whole and intersection with C, that is this C. So what will be the intersection? It will be this shaded part. So this is B bar intersection C. And the third step, we will find this whole. Okay, so that is A union this portion. So that means this portion union A. So what will be it? It will be like this. So this is the left hand side. Now again, same manner we will draw for the right hand side. So for right hand side, the first step. Now we have already calculated B bar. Now A union B bar. So that means A union B bar. So this is B bar union this A portion. Okay. So that means this portion will be added. So that is this shaded part, that is A union B bar. And next step, we will calculate A union C. So that is very easy. So that is A union C. So this will be the A union C. And final, we will find this whole. So it will be like this. And you can see that both the Venn diagrams are same. So that means it is proved. Now let us discuss some basic identities. Now let capital A, B, C be any subsets of set capital X. Okay. Then the first law, that is idempotent laws. So that is this A union A equals to A, and this A intersection A equals to itself A. So that is the idempotent law. Now what is the commutative law? Now see, this A union B equals to B union A. So that means you can change the order. Okay. Then next, A intersection B equals to B intersection A. Then next, this distributive law. Now what is that? This A intersection B union C equals to A intersection B union A intersection C. So that means we can distribute from this, that is intersection. So A intersection B union A intersection C. And in same manner, if we change the order of this union and intersection, this will be the second law. Then what is the De Morgan's law? So that is this A union B whole dash. So that means A union B whole complement equals to A dash intersection B dash. And in same manner, if we change the order of intersection and union, so that means A intersection B dash equals to A dash union B dash. Then next, what is the absorption law? So the first one is A union A intersection B. So as its name suggests, that is the absorption. Okay. So this whole A absorbing this A intersection B. So if we take A union with A intersection B, so A is absorbing this A intersection B, and final answer will be A itself. And in same manner, this A intersection A union B will be A. So it is absorbing this A union B. Then double complement law. So as its name suggests, it contains double complement. So that means A dash of whole dash, that is A. Now cardinality of a finite set. Now see, cardinality of a finite set, it is the number of distinct elements in the set. Fine. So cardinality of a set, it is denoted by this n of A or this modulus of A. For example, if we have A equals to set of all x such that 2 less than x less than 10. So this is the set builder form. So what will be the cardinality of A? So the cardinality will be 7. How? See, this set contains how many elements and which are they? So the set contains elements from 3 to 9. So it will be 7. Now let us discuss important topic, that is principle of inclusion and exclusion. Now what is that? What is the statement? Now if we take two sets, so that means this cardinality of A union B, it is same as cardinality of A plus cardinality of B minus cardinality of A intersection B. And in same manner, if we take three sets, so cardinality of A union B union C, so that is cardinality of A plus mod B plus mod C minus A intersection B minus cardinality of B intersection C minus cardinality of A intersection C plus A intersection B intersection C. Okay, we will use. Okay, now why it is called inclusion and exclusion? Because see, you can see that here we have included some portion and excluded some portion, and in same manner we have included this three terms, then excluded three terms, and again included one term. So that is why it is called inclusion and exclusion. Let us discuss example based on this. So the question is, consider a set of integers from 1 to 250. Okay, then find how many of these numbers are divisible by 3 or 5 or 7, and also indicate how many are divisible by 3 or 5 but not by 7. So we will use this inclusion and exclusion principle. So first, let capital A, B, C denote the set of integers from 1 to 250, that is divisible by 3, 5 and 7 respectively. So that means this A denote integers from 1 to 250 divisible by 3, and in same manner for B 5 and for C 7. Now see, a cardinality of A, it will be, what is A? It is divisible by 3. So that means we have numbers from 1 to 250. So integer part 250 by 3. Now see, this is the integer part. So 250 by 3, that is 83 point something. So we will just use this integer part. So that is 83. In same manner, this cardinality of B will be 250 by 5. So that is 50. It is the perfect number. Then same manner, this cardinality of C, that is 250 by 7. So that is 35. Now, what is A intersection B? So A intersection B means what? Divisible by this 3 as well as divisible by 5. So that is 250 divided by 3 into 5, that is 16. Now what is A intersection C? That is 250 by 3 into 7, that is 11. B intersection C, that is cardinality of B intersection C, that is 7. And last, A intersection B intersection C, that is divisible by 3 and 5 and 7, and that is 1. So now by principle of inclusion and exclusion, this A union B union C, and what does that mean? Numbers which are divisible by 3 or 5 or 7, and that is what we are finding. So this is the formula: A plus B plus C, A intersection B, B intersection C, A intersection C plus whole intersection. Okay, so if we substitute all these values, we will get A union B union C, and that is 135. Now the second question is divisible by 3 or 5 but not by 7. So that means, just consider A union B union C minus this whole C, that is cardinality of C. That will be the final answer. So 135, we have already calculated 135 minus the C portion, that is 35, and that is the 100. How? C divisible by 3 or 5, so that means 3 A and B. So this portion 3 or 5, so that is this A union B, and but not by 7. So that means we need to cut this whole C. Okay, so that will be this final answer, that is 100. Thank you.